I'm waiting for the students to join. Yeah. Hi, Omar. So welcome to the webinar. So my name is Prakash. I am the math tutor for this webinar. So I hope you can hear me. Hello. Can you please respond? Omar, can you hear me?
Yes.
Okay, great. So, so today we're going to discuss about the topic called the circles. So Okay, so the introduction to circles. Okay, so we'll start from the basics and then we'll go on and we'll learn some angles as well. Okay, so let's start the webinar. Okay, so I hope you're in a class 10, isn't it? So can you please confirm that so that I will teach in that way. Okay. So introduction to circles. What do you mean by a circle? So this is how actually the circle is a 2D shape, isn't it? Flat shape. So there is a plane figure which is circled the complete way. The each point. So there is a midpoint, and it is connected with around that midpoint. So it is completely closed around that midpoint. A curved line, we can say. So I hope you can see that the basic how the circle looks like. And in circle, we have radius. What do you mean by radius? Radius is the distance between the midpoint to the any edge of the circle. Midpoint to the any edge of the circle is radius. What is diameter? And you can see that in this circle we have a midpoint, which is nothing but a center, we used to call it as, and then the radius. The radius is distance from the center to any edge of the circle. Okay, so that's what. And the diameter, what is the diameter? Diameter is nothing but twice the radius, or else we can say the diameter is the distance between one edge to the other edge of the circle, which passes through the midpoint, which is center. Okay, so this is one. Let me show definitions to you. So it's radius. You can see the definition of radius. Radius is the distance from center to the any edge, or rather outside edge of the circle. Okay? And diameter is the longest distance across the circle, or else we can say diameter is nothing but the distance between one edge to the other edge of a circle. I mean that must passes through the center. So that is nothing but a diameter. And let's learn the other basics of a circle, which is what is the relationship between the radius and the diameter. So let me share the whiteboard. So as you guys know, so this is a circle and this is radius in the diameter. So it passes through the midpoint, for example, which means what? It has two radius. So this is one radius and this is another radius. I mean, both radius are same. I mean to say the diameter is twice of the radius. Okay. So the diameter equals to 2 times radius. So I'm just writing diameter as a D and radius represents R. Okay, so the diameter is 2 times of radius, or else if diameter is given, how to find the radius, which is diameter divided by 2. So this is the basic things you need to remember, you need to understand. Okay, and then the other important things in the circle, the basic things rather, we can say, what is perimeter? I think you might have the perimeter of a 2D shapes. Okay, any shape, maybe perimeter of a square, perimeter of a rectangle, and all. What is the perimeter of a circle? So since it's a circular shape, instead of calling perimeter, let's call this as a circumference. So circumference is also called as a perimeter. Okay, so since it is a circular shape, we used to call the circle as the perimeter as a circumference of a circle. Then what is circumference? The total distance around the circle. the total distance around the circle. For example, we are starting here, the point, I think you can see my writing. So the distance around the circle till the point you started. Okay, so that is nothing but a circumference, total distance around the circle. If you want me to show the definition, just have a look at this. The circumference of circle is nothing but a perimeter. What is perimeter? Which is nothing but the distance between, or rather distance around the circle. Okay, and how to find the circumference of a circle? How to find the circumference of a circle? What is the formula? So we are going to use the two ways. We can use circumference equals to 2 pi r. So this is the formula, or else we can say pi d. Okay, so both are same. I hope you know why. Because as we discussed, d equals to 2r. I hope you can see that. So c equals to 2 pi r in essence. C equals to pi into 2r. What is 2r? Which is d. So that's why we can say circumference of a circle formula is 2 pi r else pi d. Both are same, both are correct. So this is the formula to find the circumference of a circle. And what is pi? Is a universal constant. The value of pi is 3.1 approximately. Or else we can say 22/7. So again, these are the approximate values. So this is a pi value. I hope you know this. So the next thing, before we solve some questions, so let's try to learn the area. What is area of a circle? I hope you understand what is circumference or circumference or formula. Similarly, what is area of a circle? Circumference is nothing but the distance around the circle. How much distance we'll get if we calculate around the circle. That is the circumference. Area is nothing but the total area, the total space, we can say. Instead of space, we can say the total area inside the circle. So all these area is nothing but area. This is the area, right? So how to find the area of a circle? So we have either we have a radius or a diameter to find the area of a circle. The basic formula is, I hope you know that, which is pi r square. Pi times radius square, radius times radius. R stands for radius, A stands for area. Okay, so let me share that with you. Yeah, so you can see that where pi value is 3.142 and it goes on, so else 22/7. Similarly, area of a circle, just have a look at this. The formula is pi r square. The value of pi is a universal constant, which is 3.14. Okay, so let's try some questions. Omar, if you want me, if you want to interact with me, please do that. So how to find the circumference and area of a circle? For example, let's say this is a circle which has the radius of 6 centimeters. So how to find the area and circumference? So what is given? The radius is given. R value is given, which is 6 centimeters. So what is the formula to find the area? Pi r square. So pi into r square. R value, radius value is 6, so 6 square. So the area of a circle is 6 square is 36, so 36 pi. And you know that since it is the area, the unit is square units. So centimeter square or square centimeters. So I mean, this is the final answer we can say, but sometimes you might need to answer answer using, after substituting pi equals to 3.14. Okay. So please substitute that and then you will get the answer. Yeah, you will get the answer in a decimal number probably. And round that answer to two decimal places if required. We'll get approximately 113.04. So which is, you can say, if we round to whole number, we'll get 113 centimeters square or a square centimeters. So Omar, please let me know if you have any questions. Feel free to ask me. So this is how we usually find the area of a circle. What about the circumference of a circle? So what about circumference? What is the formula to find the circumference? Which is either pi d or 2 pi r. Please let me know if you want to say anything. And then you know that radius is given. So 2 times pi times 6. So 2 times 6 is 12. So 12 pi. So that's the circumference. So I will stick with that answer, 12 pi centimeters. Sometimes I think in the question, if they ask you to write it in a decimals, please go ahead and substitute the value of pi. So what is the value of pi? It's around 3.14, isn't it? So we'll get 37.68 centimeters. So that is the circumference of this circle. So I hope you're able to follow me. Please let me know if I am slow. I will try to be a little faster.
Okay.
You want me to go a little faster?
That's be better.
Okay. So would you like to try this question? So how to find, or can you find the area and circumference of this circle? Would you like to give it a try?
Okay.
Okay. So can you please tell me how?
The root for the circumference is 2 pi r.
Okay, you're finding circumference first. Okay, sorry. Okay, let me write that quickly. So you said the formula is formula for circumference is 2 pi r. Then
2 times pi times 7.
7. So I think you know that. So that's why.
Yeah.
So 7 times 2 is 14 pi. So if you want to substitute, we can do that. I mean, as I said, it's not compulsory. But if in the exams and all, if they ask you to use a decimal value, or rather use pi equals to 3.14, then you need to use that. We'll get 43.96. So if you round it to whole number, we'll get approximately 44 centimeters. So that is the circumference. I hope you understand that. So can we do can we solve area quickly?
Yes, the root is pi r squared. Yeah.
Yep.
Pi times 7 squared. 49 pi.
49 pi. So if they asked you to write it in a decimal answers, so pi value is 3.14.
Yeah.
Yeah, or else you can say 22 by 7. So we'll get the answer as approximately 154. Okay, so I hope you understand why I have written 20 by 7, which is same as the pi value. Okay, so we can use any of this. So I hope you understand since you interacted. So let's go to the next type of equations. So in a circle, we might get a question like the circumference is given. Let me just give me a second. Just a second. So they have given the circumference as 10 pi. Okay, they asked you to find the value of a radius, and they also asked you to find the what is the area of this circle. So this circle circumference is given. They asked you to find the radius and area. So do you have any idea like how to solve this?
Yeah.
Okay.
The circumference is 2 pi r. So
So
10 divided by 2 equals 5.
so 10 pi divided by 2 pi. You mean to say?
Yeah.
Okay. So then what is the value of a radius, which is
5.
5? So I mean unit is not given. Let me add the unit as inches. Yeah.
Okay.
So which
5
means
inches.
5 inches. Can you please tell me the area then?
Okay. Pi r squared. So 25 pi.
Very good. I think we'll stick to that, but make sure. I mean, you're substituting the value of pi. I mean, in the exams and all. Okay. So final question in this, then we'll move to the sectors and all. Final question would be: so there is a circle. The area is given. So area, let's say, just a second. Let's say 64 pi. So they asked you to find the circumference and the radius and the circumference and the diameter as well. Okay, let's make it in this way. So what's your first step?
The area is 2 pi, pi r squared. So square root.
So pi r square equals to 64 pi. So r square equals to 64 pi
64.
divided by pi. Okay, okay, yeah, I understand. So r value is the square of 64. You mean to say? So what?
Yeah.
Yep. So again, I missed the unit. Let's take a centimeters. So that would be a centimeters. So what about the radius then? I mean the diameter then?
The diameter is twice the radius, 16.
Yeah. So good. And finally, what is the circumference of this?
2 pi r, so 16 pi.
Okay. So make sure you are substituting the value of your pi.
Yeah.
Okay, I think you know these basics. So let's go to the, I mean, we do have one more type of a circle. I hope you know that, which is a semicircle. What do you mean by a semicircle?
It's a half a circle.
So it's half of a circle, isn't it?
Yeah.
Okay, I'm just drawing roughly, guys. Okay, I hope it's not good. Let me make it a little better. Okay. So in semicircle, it's half of a circle, one thing. So this is the complete diameter. This is a complete length. This is a diameter. And what might be the radius? Radius is, this is the radius from midpoint to this circle. So this is the radius. And do you know the formula to find the area of a semicircle?
Pi r squared over 2.
Pi r square by 2. So since it's half of a circle, so you are, I mean, going to divide the same in the area. So what about the circumference? What about the circumference?
I
So
think
circumference.
pi r plus d.
Okay. Pi r plus d. Okay. Nice. So I think you understand that. Okay. So I don't think it's no need to waste much time here. So let's go to the sectors and okay. So I'm pretty happy with, I mean, the way you answered. Okay.
Okay.
Okay, so you said the basics of the diameter, the radius, the circumference, area, and all. What you mean by a segment, or a, yeah? What do you mean by a segment? Any idea?
I actually don't remember.
Okay. So before that, let me ask you, let me explain a bit thing like what is arc? What is arc? For example, this is a radius. This is also a radius. And the mid, this is midpoint. So I think you agree with me. Like this is a radius. This is also a radius.
Yeah.
Yeah. And what about this one? It's kind of a purple line. Can you see that?
That's quarter of the circumference.
No. Yeah, I think we can say that. I mean, by the way, the amount of portion I have taken, but what exactly this means, I mean to say, it is an arc. So this is an arc. This is the arc of a circle, which means a portion of a circumference is a circle. I mean, the portion of a circumference of a circle is arc. Okay, as you said, it might be or it may be 1/4 of a circumference. I'm totally agree, but I didn't take any measurements though, but I just drawn randomly. But what do you mean by arc? A portion of a circumference. I hope you understand that.
Yeah.
So that, yeah. So that R can be half of circumference or quarter of a circumference, any part of a circumference. So for example, if circumference is 18 centimeters, just an example, that arc can be 4 centimeters, that arc can be 2 centimeters, that arc can be 10 centimeters. It doesn't matter. So any portion of the circumference is arc. So it depends how much the length of the arc differs. I hope you understand that. The next one, have you learned the degree? I mean the angles and all.
Yeah.
I mean, okay, great then. Okay, let me make one now. So you know that this is a radius. Just a second. So this is also a radius. So this is an angle. I hope you know that. And this is a radius. So this angle is called as a theta. And what is the arc here? The arc is the distance from here to here. We can say this is a smaller arc, and the other side around that might be another angle as well, another arc as well. You understand what I mean to say? This one, the blue one, the blue line. Let me draw the blue line like this. And roughly. So this is also an arc, but what do you mean by that? Then this comes for that. For a blue angle, the theta which in the blue, so that's the bigger angle. So as the arc gets bigger, the angle also gets bigger. I hope you understand that. So that's the, I mean, we are not concentrating on the blue arc now. Let's concentrate on the arc. What do you mean by the arc length? So you understand this is an arc, the pink color one. How to find the arc length? Any idea? Any
The length. No. I mean the angle, the small angle, theta. The angle
that
of
is
the
a
center
theta
over the 360.
Yeah, some way, yeah, exactly. One thing, I just need to confirm one thing, Omar. Have you learned the radians as well, or only degrees? I mean, I am talking about the angle. So have we, I think you know the angles will be there like 0 degree or 90 degree, whatever the degree. This is the per degree, and we represent the angle in degree. So we also represent the angle in radians. Have you known this? Or do you know that?
Yeah.
The angle in two ways. One is using degrees, so like 40 degrees, 30 degrees and all. And also we used to represent the angle using radians. You know that? I mean, it's fine. I will explain that. I mean, I just want to check it. Omar, waiting for your reply. Okay, so no problem. So let me recall it if you're not able to, maybe you learn and forget something. Okay. So let's say generally a one complete circle is nothing but 360 degrees. Hope you know that. So this is how we represent the angle in degrees. Okay. Angle represented degrees. So in radians is another way of representing the angle. Rather, what is the unit of angle? We can say degrees. We can also we do have the radians as a unit. For example, what is the unit of length? What is the unit of length? We can say meters, we can say centimeters, we can say kilometers, inches, yards, kilometers. I did miles. If you want to add millimeters, we can add. So all these are the, what do you call, units of length. It's unit of angle. Unit of angle is, we have a two. One is degrees, the basic one you might learn. The other one is the radians. So what do you mean by radians? Rather, how to convert? See, in the length which I have taken the example, we know that how to convert meters to centimeters, meters to kilometers, or the vice versa. So similarly, we do have a conversion. Rather, we can convert between the radians to degrees and degrees to radians. I hope you're following me. Yeah.
Yeah.
So what is radians? 360 degrees is nothing but 2 pi radians. 360 degrees is nothing but 2 pi radians. Okay. So if you want me to write some values here, just write 0 degree is nothing but 0 radians. 360 degrees in a sense, 2 pi radians. So 180 in a sense, pi radians. So similarly, for each one, like for 60 degree, for 30 degree, for 40 degree, we can find the radian. I mean, we can find the angle in radians. Are you able to follow me? Are you able to follow me?
Yeah, but sorry, your voice just cut out. Now I can hear you well.
You can hear me. So what I was saying, we can present the angle. Can you hear me now?
Yes.
Hello? Yeah.
Yes.
So what I was saying, okay. So what I was saying, we can represent the angle in two ways. One is using degrees, other one is using radians. So we can convert between radians to degrees. Okay. So that's what I was explaining. 360 is nothing but 2 pi. Okay, so 360 degrees is nothing but 2 pi. So let me show you the basic way of converting. Have a look at the board. I mean, we have two units for angle. One is degrees, one is radians. Just have a look at this. So how to convert degrees to radians? So it's not a, difficult way. Maybe it looks a little weird, but it's a very easy. Okay. Shall we do some questions?
Can you just give me examples?
Yes.
Like quarks
Yeah.
example? Thank you.
Okay, so what I said, 360 degrees equals to 2 pi radians. So this is the one you need to remember, the basic. So, and can you please tell me what is 180 degree in it? We are dividing both the sides by 2, which is pi radians. You agree?
Yeah.
So 360 in a sense 2 pi. So obviously 180 becomes a pi, because 180 is half of 360, so pi is half of 2 pi. If you know these two, I think you're fine. Then, for example, how do you convert 90 degrees into radians? I think you have an answer with you. What do you think?
Yeah, it has to be half pi.
Pi?
Half pi. Oh, yeah, pi over 2.
Half pi, yeah. Okay, sorry. Yeah, I understand. So pi over 2, very good. So pi over 2. So what about 60 degree? I mean, this looks a little tricky, but how to find? Just let me show you the formula or a basic rule to find. 60 degrees, we are converting into radians. What you need to do, a pi by 180. See, pi in a sense, pi value and 180 is same. You agree?
Yeah.
So pi, we used to, the pi is same as 180 because pi is in radians, 180 is in degrees. That's why we need to write, then you can be converting, what is that? Degree to pi by 180 times whatever the value we have. Whatever the value. We have 60 in this question. So you're going to put 60. Okay. So what will happen? See this 60 degrees. So this degrees cancels out. So we're left with, you can just check that. 6 3s, right? 180. So 5 radians. What do you think, Omar? Are you able to follow me?
Yeah.
Okay. So can you please try one question? Let's move to the next page. So what is 45 degrees? Please convert this into a radians. See, I want one. Just write pi, because radians is represented in pi. So pi by 180. Then you need to multiply whatever the question is given, whatever the number we have. So then just simplify this. See how much, what is the value we might get. I think 45 times 4 is 1. So pi over 4, and make sure you, yeah, very good, very good. So make sure we are writing the radians in it. So 45 degrees is same as pi by 4 radians. Can we try one more? Can you please tell me what is the value for 30 degrees?
Pi over 6.
Pi over 6 radians. So that's perfect. So one last one, maybe one second last one. So 270 degrees. So can you please convert this?
$1.5 pi.
I didn't get you. Sorry, one more time.
1.5 pi.
Okay. That's very nice. Okay, so you did I mean, instead of writing a decimal point, I will suggest you to write it in the fraction. Okay, so which is same as 3 pi by 2. You got that? I mean, same as 1.5. Yeah, I will suggest you to write it in a fraction. So this is how we used to convert angles into rather degrees into radians. Can we do other way around once? Other way around in a sense, you know that the basic rule pi equals to 180. If you know that, I think it's fine. More to solve questions. So let's try one question. Can you please tell me the value of pi by 5? So please convert this into degrees. This is a radians. So how do you convert this into degrees? If you want me to explain, I will do that quickly. So what you do, degree in a sense, number comes first. 180 divided by pi this time around. And whatever the value is given, which is pi by 5. Okay? And then you can see that you can get rid of pi here, and you can divide 180 by 5. And we will end up getting the correct answer. So what is 180 divided by 5? So I think 36 degrees. So pi by 5 radians is nothing but 36 degrees. Clear?
Clear.
Great. So I want you to try one more question, if you don't mind. 5 by 6, we did 5 by 10, okay? I think it's a very easy question for you.
Yeah, it was 18 degrees.
18 degrees, you understand. So, 2 pi by 3, interesting. 2 pi by 3 radians. Please work out.
120 degree.
Okay, I think you're excellent. Yeah. So I think you understand. So how to represent, or rather how to convert between the angles. So finally, I just want to say something here. I think you know the quadrants, isn't it? I think you know the quadrant. Which one is the first quadrant, the second quadrant, and all. Do you? I hope you know that. So this is a 0 degrees. This is a 90 degrees. This is 180. This is 270. And the total becomes a 360. The quadrants, this one is the first quadrant. This one is the second quadrant. This one is the third quadrant. And this is the fourth one. I think you know this, right, Umar?
Yeah.
Yeah. So can you please tell me 220 degrees comes under which quadrant? Comes in which quadrant? 220 degrees. Third quadrant, you said, I think.
Yeah.
Yeah. Very good. So can you please tell me 144 comes under which quadrant?
Can you please say the number again?
144. 144.
Second quadrant.
Excellent. So you know all these things. That's nice. Similarly, you might get a question stating that. So you drawn. So this is 0 degrees. This is 90 degrees. This is 180 degrees. This is 276 degrees. That's your final weight. So can you please tell me in radians? So this is 0 radians. This is pi by 2 radians. This is pi radians, and this one looks like a 3 pi by 2 radians. Do you agree with this?
Yeah.
So you might get a question stating that, for example, pi by 5 or whatever, so comes under which quadrant? So one thing, if I don't think it's easy to solve directly, so please convert this into an angle, I mean the degrees, then you can say the quadrant easily. I hope you understand my point. Okay, so if you convert, you will get 36 degrees. So you can say the answer, this comes under first quadrant. Okay, so you will get a question, 2 pi by 3 comes under which quadrant? So you just, I mean, sometime back you heard or you converted, which is 120 degrees. So it comes under second quadrant. So all these things, I hope you understand now. Clear with me. Any questions, Uma?
No.
No. Okay, good. So let's go to the questions now. So this is what we were discussing. So this is an arc. I think we were trying to find the arc length. So in arc length, we have a formula for arc length. We have two formulas for arc length. One is using degrees and using radians. Okay. If you know one, you can convert the other. So it's not a big, so it's an easy one. So let's try one question. Quickly, just a second. So this is the radius. This is also the radius. So let's say this is in theta. This is r, as you know. And if you want me to change the color of an arc, I will do that. Yeah. So this is the arc length. So arc length generally we used to represent it in the capital S of an arc length. Okay. So what is the arc length formula? S is equals to r theta. It's a very straightforward. This is in radians. If the angle is given in radians, you need to use S equals to r theta. You understand?
Yeah.
So if it is given in degrees, what you need to do? Any idea? S equals to theta divided by 360 into 2 pi r. You can use this, or else the one which we learned. Okay, I will write both, 2 pi r. See, you can just see the formula, nothing will change. This pi is here, this theta is here, this r is here. 360 is nothing but a 2 pi. That's what we just added because it is in degrees. I hope you understand what I mean to say. So this is the arc length formula if it is in angle. Or else we can also write it as theta by 180 degrees. Or else, let's say r theta pi by 180, or r theta, the same thing, but we are converting, so 2 pi by 360. So both are same. So you can use any of these three formulas. I think all are same, okay? So nothing, all are same as you see. So you can use any of these formulas if the angle theta is given in degrees. If the theta is given in radians, you can directly use the formula S equals to r theta. Do you have any questions in this?
No.
Shall we try some couple of questions? Okay.
Okay.
Yeah. So I have a question. I will try to draw quickly. So this is a 45 degrees. So this is 45 degrees. And this one is, let's say, 7 centimeters. So please find the arc length.
Okay, so
Can you please tell me that?
r times 7, same bracket, 2 pi over 360.
Okay, you said S equals
7,
to
7 times 45,
okay.
it 2 pi over 360.
Perfect. I think you got the concept very quickly. That's good to see. So then what you do? You multiply rather. Yeah, this 45 goes in how many times? 8 times. You agree?
Yeah,
No?
yeah, yeah.
Okay. So 8 times. And what else we have? We have a 2 at the top as you see. So we can cancel this 2 and we can make this as a 4. I hope you agree with that as well.
Yeah.
And what is the value? Which is 7 we have at the top. So 7 pi divided by 4. So it's not a radians, it's a distance, right? So whatever the we have, which is centimeter. So you need to substitute pi value is 3.14. Okay, pi value is 3.14 only when it is in a degrees mode. If it is in a radians mode, that pi value is 180 degrees. Okay, so I think you won't confuse with that. I think. Let's try one more.
Okay.
Okay, just a second. So what do you think? How much it might be? Can we take 150? Yeah, 150 degrees. And this is 8 centimeters. And this is 8 centimeters. And please find the arc length.
It will be 8, S equals 8 times 150,
150.
bracket 2 pi over 360.
Very good. Okay, please try to simplify.
8,
I think,
the 150 could
okay.
be simplified with 360, and it will be 2 pi over 2.4.
I really didn't get you. I mean, your voice is low, I think. So this is what you mean to say. I hope so. So I just multiplied 150. 15 times 8 is 120, so 1200. Then I hope we can, what we can do? We can cancel out 110. So and please check 36, 120 with 36, whether we get it something.
Yeah.
So or else we can do this 2 times 18 and then we have 18. So finally we have 120 pi over 18. Please simplify this. I mean, can be dividable by 6, I think. 6 3s are 18 and 6 2s are 12. So 20 pi by 3. Any questions in it? I mean, centimeter, I mean the unit. Any questions in it?
No.
Okay. So let's try one question using radians. I mean, if the angle is given in radians. Okay. So here it is. Let's say 60 is too less here. Let's make it as a 2 pi by 3. So this is 2 pi by 3. They have given 2 pi by 3. And this one is 10 centimeters. 10 centimeters. Please find the arc length. So this is given in radians. The angle is in radians, as you see. The middle one, 2 pi by 3. So can you please tell me, Omar, what is the formula?
Can
Arc
I
length.
replace pi by 180? So can I make it 2 times 180 over 3. Then I use the rule.
Yeah, you can use that. Okay, so what you mean to say? First, use this same formula and convert into the radians mode. I think that works. Instead, just have a look at the formula. It's a very straightforward. You don't need to do anything. You just need to times. If it is given, if the angle is given in radians, just multiply the radius and the angle. You got that?
Oh yeah, that's easy.
That's easy. You just need to multiply directly, or theta. So you know the r, which is 2 pi by
10,
3. And
10.
yes, sorry, I have written other way around, but that's fine. So you got the angle is 20 pi by 3. You understand?
Yeah.
Yeah. So you might think we got the same answer compared to the previous question, but their radius is different, 8 centimeters, but here 10 centimeter. Okay, that's why it was same actually. Okay, so I mean we thought correctly, no worries. So this is how we need to find the length of an arc or arc length. Please remember the formula. S equals to radius times an angle is, I mean, when the angle is radians. If an angle is given in a degrees, you just multiply this with 2 pi by 360 degrees. I hope that clears.
Yeah.
What do you think? Yeah, great then. Okay, that's nice. And uh, and I hope you understand the conversion between the units. So I'm not going to do that again. And what is the next topic? Let me have a look. Which is sector? Let me share that screen. Yeah, we've done all these things. Yeah, this is a sector. What do you mean by a sector?
A part of a circle.
Yeah, part of circle, area of a sector. We can see that. Yeah, exactly. The part of a circle. So which means if 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 we have an arc, see in this is an arc, this is an arc, or else the other one, the remaining one is also a bigger arc. We can say if this is a theta, but what is sector? This is the area. So this is the sector. This is a mini sector. I mean minor sector they have written. So which is small sector in this circle, and we do have other sector which is this the other length area, the remaining portion of the circle. This is a major section. You understand?
Yeah.
You got it? I mean, yeah. So in a circle, if we have one arc, obviously, it's not so easy to draw one arc in a circle, right? If you draw one arc, we do have another arc, right? The remaining portion is nothing but the remaining arc. Remaining circumference portion is nothing but the other arc. Similarly, if you draw sector, we do have a other sector as well. So we have a generally two sectors in it and a circle. If we draw one, obviously we'll get one more on the other side of it. The same thing. So if you combine both, it will get the whole area. So simply, I just want to, what do you call it, explain in a simple way. You know that circumference, and the relationship between the circumference and a what? Arc length. Arc length. So what I said, what we learned, rather, arc length is a portion of a circumference. You agree? Mo?
Yeah. Yeah.
Yeah. Yeah. Here, E and Z. Okay. So what do you mean by the sector? Okay, sorry. Yeah. Sector. So sector is nothing but a portion of a area. You agree? Is that clear? Your doubt? Yeah. So arc length is the portion of a circumference. Sector is a portion of a area. So when we are finding the arc, we are going to find the distance of that arc. When we are finding the sector, we are going to find the area of a sector. Okay, so the area. So what is the formula? So let me share that with you. So that's what. So if you want to find the sector area, so this is the sector area, the mini sector area. So what is the area? This area. That's what you're going to find in a sector. Just have a look at this. It looks a little confusing, but I hope you know this. Maybe you learned it. If not, so this is a way to go. So again, as I said, the angle, it depends on angle. We do have a formula for a theta. If theta is a degree, theta is a radians. So this is the formula when theta, the angle is degrees more. Okay. That n is nothing but a theta, but I just taken roughly there. Just have a look at that. Area of a sector divided by the area of a circle equals to the central angle divided by 360. Okay, this is not a formula. Again, I'm saying this is not a formula. By using this proportion, you can find the area of a circle, you can find the area of a sector, you can find the central angle. That's why in a simple way I have given it as the proportion instead of a formula. The formula is the below one, that is theta divided by 360 pi r square. This is the area to find the area of a sector. Omar, is it confusing?
Oh no.
So why I have
n is sector, yeah?
Yeah, n is the theta, I need to say, angle. So yeah, so why I have given the proportion? So this proportion, if you know this proportion, this helps us to solve any types of questions in a circle. Going forward, moving forward, we might need to find the area of a circle by, they might give area of a sector and a central angle. They asked you to find the area of a circle. So we can use this proportion. That's why it mentioned. Please go to the last step directly. That is the formula for an area of a sector. Area of a sector is nothing but the theta divided by 360 degrees times the area, which is pi r square. Okay. So what do you mean by that? Let me share the question to you. So please find the area of this one. Yeah. So let me draw that quickly. So for example, this one is 120 degrees. So this is 10 centimeters. This is also 10 centimeters. So, but here they asked you to find the sector, area of this sector, area of only this portion. You can find the area of a complete circle using pi r square, but they are asking only this portion. I hope you understand what I mean to say, the area of a sector. So how do you find that? Area of a sector equals to theta divided by 360. Theta is the value which we have here, and the same formula, which is pi r square. So 120 divided by 360 times pi r square, in a sense 100. So shall I write 100 pi directly? Yeah, then please simplify this and see. You know that 0 cancels out. 12 3s are 36.
One over 3.
Yeah, 100 pi over 3 is the area of that sector, that portion. Okay, so area of that portion is 100 pi by 3. And if you know that, I think you know how to find the area of this one as well. Do you? So if that is 120 degrees, can you please tell me what is the angle here? What is the angle? This one.
240.
240, 340. Yeah, excellent. So you can find this area as well, this area of a sector as well. So if you add, we'll get the complete area of a circle. So sector is the portion of an area. I hope you understand that. So I think that's it of today's webinar. The Homer. I think I pronounced your name correctly. Sorry for that.
Yeah,
And
no problem.
yeah, yeah, and let me know if you have any questions. I prepared more, but it took a lot of time to explain other things. Okay, please let me know if you have any questions. Do you have any questions?
No.
Okay. Yeah, please take care and see you in the next webinar, hopefully. Please take care and have a nice day.
Thank you.
Thank you. Bye. Take care.